Do you know how electrons in an atom filling up the atomic orbitals? In this video, I'm going to discuss 3 principles or rules which govern how electrons filling up the atomic orbitals in an atom.
The mechanics model can be used to describe the electronic configuration for many electron atoms. To describe the electronic configuration in many electron atoms, we must consider the nature of the orbitals, relative energy of the orbitals, and how electrons occupy the available orbitals. In many electron atoms, the energy of an orbital increases with increase in n. For example, if comparing 1s with n equals to 1, 2s with n equals to 2, and 3s with n equals to 3, the energy of the orbitals increases in the order of 1s, 2s to 3s as the n increases. For a given n, the energy of atomic orbitals increases with L, the angular momentum quantum number. For example, for n equals to 3, the energy of the subshell increases in the order of 3s, which has L equals to 0, to 3p, where the L is equal to 1, to 3d, where the L is equal to 2. Electrons fill out the atomic orbitals based on 3 principles or rules. The first principle is called Aufbau Principle. According to Aufbau Principle, electrons arrange in atomic orbitals in the order of increasing energy level. The energy of atomic orbitals increases in the order of 1s, 2s, 2p, 3s, 3p, 4s, 3d, 4p, and so on. So how do we get this order? So to get the order, first we need to list out the subshells involved for each energy level. For example, n equals to 1, we have 1s subshell. For n equals to 2, we have 2s and 2p subshell. And for n equals to 3, we have 3s, 3p, and 3d subshell. And for n equals to 4, we have 4s, 4p, 4d, and 4f subshell. And n equals to 5, we have 5s, 5p, 5d, 5f, and so on. After we have listed out all the subshells, then we can draw arrows diagonally through each of the subshells. So for the first arrow, it passes through 1s subshell, so means that 1s subshell is of the lowest energy level. And the second diagonal arrow passing through 2s subshell, so means that after 1s subshell, it will be followed by 2s subshell. And for the third arrow, you can see that it will pass through 2p subshell first, so means that after 2s, it will be followed by 2p subshell. And then for the third arrow, after passing through 2p, it also passes through 3s subshell, so means that after the electrons fully fill the 2p subshell, it needs to fill 3s subshell. And for the fourth arrow, can you see that when we draw diagonally, it passes through 3p subshell first, so means that after fully filling the 3s subshell, the electrons must go to 3p subshell. After fully fill the 3p subshell, it will go to 4s subshell. And then the next arrow, diagonal arrow, we get the arrow passing through 3d subshell, so means that after fully filling the 4s subshell, it will fill 3d subshell. After fully fill the 3d subshell, it will fill 4p subshell. And then after fully fill the 4p subshell, it will fill the 5s subshell, and so on. According to Aufbau Principle, the electrons arranged in atomic orbitals need to be arranged in the order of increasing energy level. So means that the orbitals or subshells with lower energy must be fully filled with electrons first before filling the subshell or orbitals of higher energy. The second principle is Pauli's exclusion principle. According to Pauli's exclusion principle, no two electrons in an atom can have same set of 4 quantum numbers. For a given orbital, the values of principal quantum number n, angular momentum quantum number L, and magnetic quantum number n are fixed. Therefore, to satisfy Pauli's exclusion principle, the two electrons accommodating same orbital must have different electron spin quantum number. For example, 1s orbital has principal quantum number 1, angular momentum quantum number L 0, and magnetic quantum number n 0. In order for the two electrons accommodating 1s orbital not to have same 4 quantum number, the first electron must accommodating 1s orbital with clockwise spinning to give the quantum number 1, 0, 0 positive half. And the second electron must accommodate 1s orbital with anti-clockwise spinning to give the magnetic quantum number 1, 0, 0 negative half. So to conclude, an orbital maximum can accommodate 2 electrons. When 2 electrons accommodate same orbital, they must have opposite spinning direction. There are some orbitals in a given subshell that have same energy, and these orbitals of same energy level are said to be degenerate orbitals. For 3D subshell, for example, there are 3 orbitals that are degenerate of same energy level. The third rule is Hund's rule. When filling the degenerate orbitals, the electrons will occupy the degenerate orbitals singly with same spinning direction first before pairing out. For example, oxygen with 8 electrons, according to the Aufbau principles, the lower energy orbitals will be fully filled first. Then, to fill the degenerate orbitals of 2p subshell, the electrons will fill the orbitals with same spinning direction first before pairing out. So means that to fill the 3 degenerate orbitals in the 2p subshell, the electrons will fill each orbital singly with same spinning direction first before pairing out. To write the SPDF notation for oxygen atom, so basically for the 1s orbital, it is filled with 2 electrons. So in the SPDF notation, we write 2 superscript to represent the 2 electrons in the 1s orbital. And for the 2s orbital, it's also filled with 2 electrons maximum. Therefore, we write as 2s2. And the 2 superscript again is representing 2 electrons in the 2s orbital. And in the 2p subshell, there are total 4 electrons, so we write as 2p4. And the 4 superscript represent the total 4 electrons in the 2p subshell of oxygen.